I received several requests from students asking me to do videos about the required practical for AQA A Level Chemistry Paper 3. For the sake of time, I may not be able to cover everything, but I will try my best to at least cover some of these. And this is the first series of these videos, and this one is about calorimetry. In the calorimetry experiment, we measure the enthalpy change either of combustion, of a reaction, or of solution, or even enthalpy change of evaporation. So in the lab, as a required practical, what you need to understand is how to set up the experiment. If it's for a combustion, then you would need to use a calorimeter, which can actually be well isolated to reduce the heat transfer to the surrounding or heat loss to the surrounding. You would use a copper calorimeter because it can transfer the heat easily from the burner to the water. And then you add a certain volume or a certain mass of water that we're going to use it in the calculation. And then before you start burning your fuel, you will have to measure the temperature of water for 4 consecutive minutes. And then you start to burn the fuel, and the change in the temperature of water will be measured using the thermometer. Remember that the thermometer bulb has to be immersed completely in the water. At the end of the experiment, you're gonna measure the change in the mass of the fuel, which is the mass of the fuel with the burner before and after the experiment, and the change in the temperature of the water at the beginning and at the end of the experiment. And then you're going to use your equations to calculate the heat transferred during the experiment. And then at the end, you're going to calculate the enthalpy change. If you are doing the experiment to calculate the enthalpy change for solution, then in this case, you're going to use a polystyrene cup because it has good insulation. And then you're going to add a certain volume of water in the same way, measure the temperature for 4 consecutive minutes, and then open the lid and then add your solid that is going to dissolve in water. When you add it rapidly in one portion. You don't add it portion wise. And then you're going to measure the temperature change for every 1 minute. And then at the end, you're going to do the extrapolation method to accurately calculate the change in the temperature. So first of all, the first line, the horizontal line here at the left, is the temperature before the addition of the solid or before the beginning of the reaction. So at the minute 4, you added your solid, or you started the reaction basically, and then you started to measure the temperature from minute 5 again. So you can see this one from minute 5, 6, and so on. There is an increase in the temperature, and then the temperature starts to decrease. Now, to accurately measure the maximum temperature reached by the reaction immediately after the reaction, you do extrapolation for this part of the curve and the other one, and then you see what is the temperature when these two meet at exactly 4 minutes. So this is Tmax, or the temperature after the reaction. Then your equations, so your equations here are Q equals mc delta T. M here will be the mass of the water, or the mass of the solution used, and C is the specific heat capacity for water provided to you, and then delta T is the temperature change. Delta H will equal Q over N. Remember that delta H will be in kilojoule per mole, so the Q here we measure or we calculate as in joules, so we have to change it into kilojoules in the other equation, and then divide by the number of moles. What are the sources of inaccuracy for this particular experiment, which is the type of questions you would get in your exam? First of all, the heat transfer to the surrounding due to the improper insulation, and this would make the reaction less ectothermic or less endothermic than it should be. And assuming that the specific heat capacity of the solution equals the specific heat capacity of water. So if you are doing a reaction with different reactant, the specific heat capacity of the solution now is going to be different, but we assuming it exactly the same like water. Assuming that the density of the solution is the same like water, 1 gram per centimeter cubed, which is not the case. Incomplete combustion in case of combustion, and evaporation as well. So the fuel could evaporate, and also water that is heated or is used in the system could evaporate. So what type of question would you expect in your exam? Sometimes they might ask you to run the experiment or describe the experiment yourself, or they could get you the simple experiment, or they could get you any different type of calorimeter. So this one from 2020, where they used a bomb calorimeter to accurately determine the heat change during a combustion of a fuel. Here they used something called the total heat capacity of the calorimeter. Here they used it, and they provided you with the equation, which you're not familiar with, which is Q equals the C of the calorimeter times delta T. And then they wanted you to calculate the heat energy released calculate the heat capacity of the calorimeter, or in the calorimeter. In this case, you will have to calculate first the heat transferred during the experiment, and then you're gonna calculate the Q, and then you're gonna use it to calculate the C of the calorimeter. How to do this? First of all, you need to use the equation, which is delta H equals the Q over N, and then you're going to calculate the Q, which equals delta Q times N, which is the number of moles that actually combusted during the experiment, and then you're going to use this to calculate. One of the typical questions about calorimetry as well is about the uncertainties and how to reduce the percentage uncertainty for the thermometer. Normally, if you are taking two measurements, one at the beginning of the experiment and one at the end of the experiment to measure the temperature difference, then the relative uncertainty will equal the uncertainty of the every single measurement times 2 divided by the total value of the temperature change. So to decrease the percentage uncertainty, you would need to increase the temperature change. And to increase the temperature change, you could, if you are doing combustion, then you can either burn more of your fuel or use less volume of water. And if it's for a solution, enthalpy of solution, then you could use more mass of your substance that you are dissolving. So let me know in the comment section which experiment do you want me to go over as well today, because I will not be able to go over everything. And the one that will have more comments or more likes in the comment section is the one that I'm going to do next.